So the probability that a full sib, that is your brother or sister, they're not identical twins, has a given genotype for a homozygote is 1 plus the allele frequency of whatever that allele is, squared over 4. And then the heterozygotes are what you see there for 2 alleles. So that's how the paternity calculations work. You know, it's give or take, it's around a quarter per locus. And K is the number of loci. So the probability that 2 full siblings have a given genotype, that's 2 alleles, is 1/4 to the K, K being the number of loci. Because the probability that they have one allele is what? From one parent. Right. You get one from one chromosome or the other, right? Probability that they have an allele from the other parent is half. What's the probability that they have both? Half times a half. Okay. So for a genotype, that's 2 alleles, 1/4 to the K. K being the number of loci. You can see that when you get to 13, the probability that 2 full sibs are going to have the same genotype across 13 loci. Now, you know, you're assuming that parents are heterozygous too, right? If the parents are homozygous, then the probability of getting it is not. It's 1. But on average, you could even multiply that by 0.8, because 80% heterozygosity, right? Still going to be pretty small. 1 in that's like almost 80 million. You follow me? So these systems can even discriminate amongst first-degree relatives pretty well. You have enough loci. Maybe one locus you may not be able to. It just depends on the genotypes. But over 13, you're getting enough genetic information to discriminate between them.